Hey guys, welcome to today's class. Have fun.
Today I'll be talking about density. Density is simply the ratio of the mass of a substance to its volume. Density is represented by rho. This is the symbol for density, and it has a SI unit of kilogram per meter cube. So what this is basically telling us is that when you want to determine density of a substance A of unknown density, so we need to take the mass, which is in kilogram. So a simple experiment to determine the density of this substance is to take a required volume of water. Now, on dipping this object into the water, we observe that the mass of this substance displaces a certain volume of water. So, by that simple relationship, you can say the density equals to the mass over the volume of displaced water. So simply, density is equals to mass over volume. So it is represented by rho, and it has a unit of kilogram per meter cube. Density of different substances is substance A and B. A, which has a mass of 5 kg, B has a mass of 3 kg. On placing A in, let's say, 10 meter cube of water and B in also 10 meter cubes of water, the density of A, which is 5 over 10, is not equals to the density of B, which is 3 over 10. So this tells us that different objects, different substances have different densities. So next we have relative density. Like the name implies, relative. When you're talking about relative density, you're trying to say it is the ratio of the density of a substance to the density of water. Now, water is the standard substance in which we compare the densities of other substances to. So when I talk about relative density, the relationship between the density of that particular substance and the standard density of water gives us the relative density. So since it is just a comparison, it has no units, it can also be known as the specific gravity of the substance. So we should also note that the density of water is equals to 1 gram per cm cube, which can also be 1000 kilogram per meter cube. Okay, so I'll be talking about Archimedes' principle next, and I'll be using a simple illustration to represent that. Now, Archimedes carried out a simple experiment. Let's say we have a box. He measured the weight of the box as W1, the weight in air. Then he took the substance and lowered it into a certain volume of water. He repeated the same thing, took the same substance, dipped it into, let's say, mercury. So what Archimedes discovered was simply, at the first instance, when he dipped the box into water, a certain amount of water was displaced. Let's keep this in mind. And also on dipping the box into mercury, a certain amount of water was displaced. Now, what do I mean by this displacement? On dipping this box into water, you realize that the level of water here pushes forward, it comes upward, and also the level of mercury here also might also move upward a bit. So Archimedes observed a certain number of things. He also observed that as the mass of this box increases, as the mass increases, the density decreases. What this means is that on putting a mass of 1 kg, a mass of 1 kg has a lower density compared to a mass of 10 kg in the same volume of water. So in general, Archimedes' principle states that when a body is completely immersed, completely or partially immersed in water, it experiences an upthrust, which is equal to the weight of the liquid displaced by it. So what does this tell us? When you immerse a body in a volume of water, now this body has a weight, which is mass times gravity. On putting this body into water, there is an upward force exerted by the water body. This upward force is known as upthrust. So the upthrust tries to counter the weight of the body. So Archimedes' principle states that when a body is completely or totally immersed into a liquid, it experiences an upthrust, which is equals to the weight of the substance. So what this is trying to tell us that upthrust equals to the weight of the substance. So looking at upthrust now, upthrust is the upward force exerted by an object to oppose its motion downwards in the fluid. So this force exerted by the liquid here is called upthrust. This is the upward force to oppose the motion downwards down the fluid. So this force upthrust depends on a certain number of characteristics. So when we have the first one here is density, a body of large density now. So when a body has a large density, what simply happens is that when it has a liquid now that has a large density, on placing an object into it, the object is going to experience a large upthrust. So what this means is, on placing this body into water, now if this liquid is so dense, it is very thick, the layers have close forces, high viscous forces. So as this mass comes down, what simply happens is that this liquid has a higher force, a higher upthrust to be able to resist this ball from sinking. Also, the volume of the solid also is a characteristics of the upthrust. Large volumes of the solid will also require large forces to resist their downward movement in the fluid. Now, the nature of the solid, whether it is a regular solid, it's an irregular solid, also gives us what we should expect about the opposing force, which is the upthrust. The shape of the solid, the size of the solid. Of course, you expect a small solid to have a smaller upthrust when compared to a larger solid, which has a larger upthrust. Also, the volume of the container. The volume of the container determines the volume of the liquid which we have, and the larger the liquid, the larger force is required to resist the opposition. So a simple example is, you have a cup of water and you throw a small stone into it, and you have a large body of water and you throw a stone into it. we are going to have a different amount of upthrust. The upthrust which the glass of water is giving is going to be different from the upthrust which the ocean is going to be giving. Of course, you know that the upthrust the glass is going to be giving is going to be more when compared to the ocean, because the ocean has a larger volume while the cup is just a restricted volume. So it's going to give more force to the downward movements of the substance. Okay, so moving to relative density of a liquid. The same way in which we can determine the density of a solid by simply saying mass over volume, is also a way we can determine the density of a liquid. In determining the density of a liquid now, we require different parameters. So in carrying out the relative density of a liquid, we need to take note of three parameters. We have an object, let's say a ball now. Now the first thing is to carry out the weight of the object in air, which is W1. W1 is the weight in air. Next is W2. We take the weight in liquid. So we insert it into the liquid of unknown density. Insert the ball into it. The weight of this object in the liquid, of which you don't know its relative density, is W2. And also we insert the object in water, the weight in water. Insert the object again. This is water now. Now, why do we use water as standard? Recall that we know the density of water to be 1 gram per cm cube, or 1000 kilogram per meters cube. So on doing this basic relationship exists, which is W1 minus W2 over W1 minus W3. So on doing this, we are going to get the relative density of that particular liquid which we are observing. So I'll be taking an example soon. So quickly, we're going to be looking at the principle of flotation. We'll be able to establish what density is, how density depends on the mass, the volume. So what's the principle of flotation simply tells us? We are able to establish the density of the substance, the density of the liquid, the relative density, how the mass and volume gives us the density. So on flotation now, the ability of substances to float in water or liquids. So we have a body, a mast, so I'm placing this object into the, let's use water as the fluid now. The body has a weight W. The object has a weight W. The liquid also exerts an upthrust to you, which I'll be able to establish earlier. On inserting this object W into the water, in cases where the weight of the object W is lesser than the upthrust. What does this mean? You insert an object with a weight. The upthrust is greater than the weight of the substance. Definitely, the substance would float. Peradventure, the weight when the weight is less than the object comes upward. That is, it won't sink. So when the weight is equals to U, the weight here is equals to the upthrust. Also, the object would float, but in this case, it is in equilibrium. Now we shouldn't confuse these two. You insert an object into water, the object begins to go down, but once the weight is lesser than the upthrust, the object begins to come upward. That is, it comes up. So on coming up is able to attain floating. It is coming up. But when the weight is equals to the upthrust already, the object floats. It is stable. It is in equilibrium. In other case, when the weight is greater than the upthrust, in fact, a body whose weight is far bigger than the upthrust which the liquid can provide to it, definitely it would sink. So quickly we'll be taking some examples on calculations in density, relative density, and upthrust. So it says an alloy consists of 70% aluminium and 30% magnesium by mass. What will be its density if the density of the aluminium is 2700 kilogram per meter cube and this is the density of magnesium? Okay, we have an alloy. An alloy is a mixture of two metals. Aluminium has its own density and magnesium has its own density. Remember that density is a relationship between the mass and the volume. In this case, we don't know the volume in which these metals obtain and the volume which they occupy in the alloy. So the first thing to do here is to find the relationship between the density, the mass, and the volume. Then on finding that, we can combine them to find the density of the alloy itself. So we are given that the density of aluminium is 2700 kilogram per meter cube. We're given the density of magnesium to be 1740 kilogram per meter cube. So recall that density is mass over volume. We are told the relationship between their masses. We have their densities. We need to find their volume. So to get our mass, the masses now, we are told that the alloy consists of 70% of aluminium, 30% of magnesium. So we can simply just say that we have an alloy of 100%. We say we allocate, let's say 70 gram is for the aluminium and 30 gram is for the alloy. So what this basically means that is percentages. It is we are using the percentages of their masses, the masses which we don't know. So using the relationship, just C is equals to mass over volume. For aluminium, that's a density of 2700. Using the relationship between their masses now, we use that 70% of its mass. We don't know the volume which it occupies. So to find the volume, we have 70 divided by 2700. This will give us 0.026 meter cube. Same way we find for magnesium. The density of magnesium is 1740. The mass ratio, that's 30. We don't know the volume, so it gives us 30 over 1740. The volume gives us 0.017. Okay, we'll be able to find the mass, the volume, and we have the densities. So we are asked to find the density of the alloy. So the alloy now, which is a mixture of aluminium and magnesium, all we simply need to do is to add the densities of these two alloys together. Okay, so the density of the alloy now is mass over volume. The mass, which will be established as 100%. On combining the two, they have the mass of this, and on combining their volumes occupied, That's 0.026 plus 0.017. We have, when adding these two, we have 0.043, which gives us the density of the alloy as 2,325 kilogram per meter cube. So we have two other examples. We have, says, what is the mass of a rectangular block of density this that measures 10 centimeter, 5 centimeter by 4 centimeter? So we'll be given the dimensions of the block and the density. We're asked to find the mass. So we are given a rectangular block. Okay, so we are given the dimensions, the length, which is 10 centimeter, the breadth, which is 5 centimeter, and the height, which is 4 centimeter. We are also given its density, which is 2.5 times 10 raised to the power 3 kilogram per meter cube. Remember, this is the unit for density. So we are asked to find the mass, which is going to be in kilogram. So the first thing to do is to convert our dimensions to meter. Recall that 1 meter is equals to 100 centimeter. So using this, so if 1 meter is 100 centimeter, so 10 centimeter becomes 10 divided by 100, it becomes 0.1 meter. This becomes 0.05 meter. This becomes 0.04 meter. So recall that density is equals to mass over volume. We have to find the mass. The mass is equals to density multiplied by volume. We have the density already, but we don't know the volume. So you can recall that volume is equals to area times height, and area is length times breadth times height. So the mass is equals to density multiplied by the length multiplied by the breadth multiplied by height. So which gives us our mass, the density, which is 2.5 times 10 raised to the power 3 multiplied by the length, which is 0.1, the breadth, which is 0.05, and the height, which is 0.04. And multiplying these three together, I'm going to have 0.5 kg. So 0.5 kg is the mass of the rectangular block which we are asked to find. So the third example here is an object weighs 10 Newton in air, 7 Newton in water. What is its weight when immersed in a liquid of relative density 1.5? So an object weighs 10 Newton in air, the W1 is 10 Newton, and it weighs 7 Newton in water, W3 is 7 Newton. It's to find the weights when it is immersed in a liquid. The liquid, which is W2, the relative density of that liquid is 1.5. The relative density 1.5. Recall that relative density is equals to W1 minus W2 over W1 minus W3. So which gives us the relative density, which is 1.5, W1, which is 10, minus W2 all over W1, which is 10, minus W3, which is 7. So this gives us 1.5. 10 minus W2, 10 minus 7, which is 3. Cross multiplying now. 3 multiplied by 1.5 gives us 4.5. And we have this 10 minus W2. So W2 taking W2 to this side, bringing 4.5 to the other side. W2 is equals to 5.5 Newton. So you'll be able to establish that the weight of the object when measured in air is 10 Newton. When the object is immersed in water, the weight becomes 7 Newton. And when it is immersed in a body, in a liquid of relative density 1.5, you can see that the mass decreased further to 5.5 Newton. So what we'll be able to establish here is an object on placing in different liquids of different densities, the weight of the object decreases when there is an increase in the density of the liquid. The density of water here is 1 gram per cm cube. The relative density of the liquid here is 1.5. So it tells us that as we have liquids with higher densities, we are going to have a decrease in the mass, decrease from 10 Newton to 7 Newton to 5.5 Newton. So that should be all. Thanks.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We will love to help you further. See you in the next class.